Let's look at lesson 10.2, graphing ax squared plus bx plus c. We're going to look at all the pieces now and how they play together. Again, I'm going to draw over here my parabola. Now, in the past, I've been centering it and calling it the parent function. Now, I'm going to do something a little bit different. I'm going to keep my x and y axes right here, but I'm going to shift my parabola over a little bit, and I'm going to do it in a different color so we don't mix it up with the parent function. So I'm going to draw my parabola just about, let's see, here. And what I want to show you is that through the center of this parabola, we have what I showed you in the last lesson, which is the axis of symmetry. And you're going to want to label that. And we're going to show you how to calculate it very soon. I'm going to show you something else as we look at that. And we talked about this a little bit in class when we started this lesson. I'm going to show you right here, this point. Now you'll notice this is where the parabola intersects the y-axis. And this is the point, x is 0 here and y is c, right? So this is the point 0, c. And that is actually the y-intercept. So let's look at this parabola in more detail and examine it a little bit. We'll notice in this situation, right, if the basic equation for this parabola is y equals ax squared plus bx plus c, if a is greater than 0, the parabola opens up, right? If a is less than 0, the parabola opens down. Remember, it's a reflection. That's what we were calling it. If that same value of a, right, is greater than 1, and we just looked at that a few minutes ago. If a is greater than 1, then it's going to be a stretch compared to the parent function. If that a is less than 1, but still greater than 0, right, it's a fraction or a decimal, it's going to be a shrink compared to the parent function. So a shrink is wider, right? And a stretch is narrower. So that is not new. We've talked about all these things before. So what is going to be new here? Well, we're going to be talking about the axis of symmetry. And they cheat a little bit when they teach you the axis of symmetry because they teach it to you before the quadratic equation, but really it's actually a piece of the quadratic equation. And at some point I will derive it for you so you can see that. So the axis of symmetry right here has, this is a x equals, right? This is for all of these, this is good for any y value, but it's for whatever this x value is here, right? Well, that x value, that coordinate, right, is going to be equal to negative b over 2a. So in case you're wondering what that negative b over 2a is, go back up and look here. ax squared plus bx plus c. There's your b, there's your a. And we're going to look at how we calculate that in a minute. this axis of symmetry goes right through here, right? Which means it's the vertex. Well, that vertex, this is the x-coordinate of the vertex right here. So that x-coordinate is going to be negative b over 2a. And we're going to calculate the y-coordinate by subbing that value into our equation to work it out. Finally, to point out something else I've already just shown you, we have this, and this is the y-intercept. Is going to be at 0c. And you can see that that is where it's intersecting. Just to show you something that the book is not mentioning, but I want to connect it to what we did last chapter. Do you remember when we were finding the values of x, right? When we factored these functions out and we found out the x values, there, right here, are your x-intercepts. So you can see the whole picture. You've got your axis of symmetry with your vertex, this is your x-coordinate of your vertex, is that axis of symmetry, the x value. Here are going to be your x-intercepts, your y-intercepts, and we're starting to get a few of the pieces of this parabola, which is used so extensively in so many real-life situations. We've looked at the projectile when you throw something, but there are so many more. I'm going to stop here and pause and do some exercises to work out some details of this parabola in a minute.